This series of videos will take you through the solutions to the Module 2 practice test. This practice test covers the types of questions you might see for your Module 2 test, which includes the topics of scientific notation and exponent laws, perimeter area, volume, and surface area calculations. Remember to also use the topic videos as well as your worksheets and quizzes to help review for the test. This first video will take you through the solutions for page 1. The first question has us converting between standard form and scientific notation for very large and small numbers. Remember that in scientific notation, we're writing a number that has a coefficient and a power of 10. The coefficient always has only one digit to the left of the decimal. In the first examples, we'll convert from standard form into scientific notation. If I look at my first number, that means I want the decimal here between the 2 and the 5. So there's only one digit, the 2, to the left of the decimal. I only write the significant digits, remembering that these trailing zeros are not significant. So my coefficient would be 2.561. I'm going to multiply by a power of 10, so times 10, and then I figure out how many places I had to move the decimal. My decimal was originally here at the right of the number. I moved it 1, 2, 3, 4, 5, 6, 7 times. So in scientific notation, this is 2.561 times 10 to the power of 7. It's a positive exponent because this was a large number. Same idea for my second example. I want the decimal so that there is only one digit to the left. So my coefficient will be 7.81 times 10. And then I figure out my exponent, how many times I had to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8 times. Because this was a small number, it's a negative exponent. So 7.81 times 10 to the power of negative 8. Going the other way from scientific notation to standard form, I have my coefficient 2.3 times 10 to the power of 8. The positive exponent tells me this was a large number, so I'm going to be moving my decimal to the right 8 places. So 2, moving it past the 3 is 1 decimal place, and then 7 more, I'll add the zeros, 1, 2, 3, 4, 5, 6, 7. So total, I moved my decimal 8 times, 1, 2, 3, 4, 5, 6, 7, 8, to convert from scientific notation to standard form. In the last example, my exponent is a negative, so I'm moving my decimal to the left 5 places, 1 to get to the other side of that 5 and the coefficient, and then I'll add zeros, so I'll need to add 4 zeros. So 0.00057. You can always check your answers by converting from standard form back to scientific notation to make sure you get back to where you started, or from your scientific notation back to standard form. In the next question, we're simply using our calculator, using some of the power and radical functions and calculating, and we'll round our answers to 2 decimal places if we need to. In the first, we want to find the 4th root of 18, so we can use our calculator, which I'll pull up to calculate these. So for this first one, I want the 4th root, so 4, second function, my radical sign, and 18. Equals 2.05976, so I can round that to 2 decimal places, 2.06. So we have the answer recorded in there now, 2.06. We can do the next question on the calculator. I'll clear this out. We want 1.3 squared plus the square root of 5. We get 3.92606, so rounded to 2 decimal places, this will be 3.93. So our second question rounded answer is 3.93. We'll do our last example, clear the calculator, 4 to the power of negative 2. So I can use my y to the x key to put any exponent I like, negative 2. 0.0625 to 2 decimal places is 0.06. In the final question on this page, I'm going to do some unit conversions now when I have squared and cubed units. And for full marks, I need to show the complete conversion factor, and I'll round my final answers based on accuracy or precision, which remember it means I'm looking at the number of significant figures in the original measurement. For the first question here, we have 182 square feet, and we're converting to square yards. So I start with the measurement I was given, 182 square feet. I want to convert to square yards. On your conversion factor sheet, you have a linear conversion. 1 yard is 3 feet. I'm setting this up so feet are opposite, so on top of the measured value and the bottom of the fraction. However, I need to square these units, so I want square feet and square yards. If I square the units, I need to square the numbers in the conversion factor as well. Now square feet will cancel out, and I'll be left with square yards. On the calculator, I can do 182 divided by 3 squared, and I get 20.2222. My initial measurement is 3 significant figures, so I'll round this the same, 20.2 square yards. We'll look at similar steps for the next question. I want to convert 164 cubic inches to cubic feet. So I start with my measurement, 1,654 cubic inches. I want to convert that to cubic feet to cancel out units. Inches will need to be on the bottom, feet on top. I know my linear conversion, 1 foot is 12 inches. If I want to convert that to a cubic conversion, so I have cubic inches and cubic feet, I cube the numbers in the conversion factor as well. Then on my calculator, I can do 1,654 divided by 12 cubed, and I would get 0.957175. My initial measurement is 4 significant figures, so I'll round to the same, 0.9572. And my new units are cubic feet. In the final example, I have 1.56 square meters converting to square centimeters. So I start with what I'm given, 1.56 square meters. My unit conversion set up to cancel out meters, so it goes on the bottom. I want centimeters on the top. I know there are 100 centimeters in 1 meter. If I want to square the units, I square the numbers in the conversion factor as well. So I can do 1.56 times 100 squared is 15,600 centimeters squared. There were 3 significant figures in my original measurement, and there are 3 in my final answer, remembering those final 2 zeros are not significant. This is the solutions to the first page of the Module 2 pretest. The next video will take you through the second page.